All right, what's up, guys? We're doing question 1.2 on week 7, show the probability, and we have a midterm question that'll be a good review on counting. So let's start with that. Let's go for the problem. Let S of n be the number of ways to add up ones and twos to obtain n or order matters. Then I have a little example that they also gave us. So for S sub 3, it can be done as 1 plus 1 plus 1, 1 plus 2, and 2 plus 1. And they're asking us to give an expression involving a summation for S of n. So let's first look at like the basic case here. If we were to only have ones, I feel like it's easier to start like this. Then we would have n slots to put our ones, right? But the thing is, we can also put in twos. So every time we put in a two, let's say we're putting in k2s, we lose 2k spots, 2k slots. But then every time we put a two in, that's also taking up a new slot. So in total, we have n minus k slots to work with. And now that we have our total slots, if we're putting in k slots, it's just a matter of choosing from our total slots where we put those twos, those k slots that represent twos. And now the question is, what's the maximum number of twos we can put within n? And that is just going to be n over 2, because you can only put a maximum of n over 2 twos in n. So now we have to sum over all the possible ways we can do this. And we can do that by making a sum from where there's 0 twos to the maximum number of twos of our total number of slots every time we choose a 2. And then this n minus I choose I represents the total number of ways that we can put twos in our n minus I slots, giving us all possibilities at each time that we put in another 2, and then summing it gives the total number of possibilities. And now for B, we are being asked to give a recursive expression for S of n for n greater than 2, greater than or equal to 2. And then you can assume that S of 0 is 1 and S of 1 is 1. So I feel like with this problem, a good place to start is probably going to be like the most basic case, right? They're telling us that this holds for where S of n is greater than or equal to 2. So let's just test that out, S sub 2. And they're telling us that that's equal to, um, we're told that, let's first look at 2, right? How many ways can we arrange 2? It can be arranged as 1 plus 1, and it can be arranged as 2. So we now have to give a recursive expression for any n. So um, we know that this is going to end up being 1 plus 1, because there are 2 total ways. And of the 2 total ways, there is one way here that starts with a 1, and then one way here that starts with a 2. So now let's look at S sub 3. S sub 3 can be done as we had in the example before, 1 plus 1 plus 1, 2 plus 1, and 1 plus 2. There are there is one way that can be 2 ways that can be done with a 1, and then one way that can be done with a 2. And we know here that our total should be 1 plus 1 plus 1. So let's try to think of what we can do here, right? We have one of the things that we can see that differs is the the starting digits in each sequence. It starts with a 1 here and then a 2 for S sub 2. For S sub 3, it starts with a 1 twice. And then we have it's starting it with a 2 once. We know that S sub 2 is 2. And we know S sub 3 needs to equal 3. So we could express S sub 3 as like S sub 2 plus 1. And let's think about what this really means, right? S sub 2, in this case for S sub 3, represents the number of ways that, as we can see here, number of sequences that start with 1. And then this right here represents the number of ways that start with 1, or start with 2. And then if we go back here, um, we're also told that we can assume that S sub 0 is 1 and S sub 1 is 1. So we would say here that S sub, we'll call this, I mean, it doesn't really matter, but S sub 1 here, and then S sub 0 here, where we can kind of like map um, S sub 1 as one way that started with 1, and then S sub 0 is one way that started with 2. And then I don't know if you can see it, but there's kind of a pattern where for every term that starts with a 1, you kind of just subtract 1 from your n. And then for every term that starts with 2, as we see here, right, we subtract our n by 2. So that holds here, obviously, where we're told S sub 1 is 0 and S sub 0 is, I mean, we're told S sub 1 is 1 and S sub 0 is 1. Then we add them up, we get 2. We can kind of see that here too with S sub 3. We know that the total is supposed to be 3. And we write it out as a sum of S sub 2, which we know is going to be 2. And then our 1 is, our 1 here can be represented as S sub 1, as we know that's 1. So with all this information, we can then write this out as a recurrence, I mean, a recursive expression saying that S sub n is equal to S sub n minus 2, S sub n minus 1, representing the number of ways that start with 1, and then S sub n minus 2, representing the number of ways that start with 2. And that concludes question 1.2 on the week 7 review sheet. See you next time.